Or please select how you're feeling today. There's a plus or a minus. You can add a number to more than one zone. If it is split up, then head to your seat. You can pick more than one if you're feeling more than one thing. Pretty good. I'm gonna say I'm feeling kind of tired and happy. Okay. So okay. Is somebody feeling excited, frustrated, upset, or worried? Which one? Which one? All of them? Okay. Most people are in the blue. I'm guessing more of a tired than most. Okay. So we have lab today. You're gonna grab goggles in a minute, like usual. If I'm wearing goggles, you're wearing goggles. Pencils. Don't forget, tomorrow is your final exam for 7th period. Our class will be shortened, so this is the last long class period. We're almost there. 4 more days. Okay, last 3 half days. If you need your exam times or whatever when you're taking it, for me, we guys are Wednesday first block, okay? So I won't see you at all next week till Wednesday, okay? Okay, so we're gonna move into the lab. And then in a second, I'll pass out our sheets. So we're doing a gas law activity. Go ahead and start your warm-up. You can either scan the QR code or on Google Classroom, if you do not have your phone, I have posted the link. So if you don't have your phone, you're doing it on your Chromebook. If you have your phone, scan the QR code. It's about 5 questions. It's about states of matter and properties of gases. So go ahead, I'll give you guys a few minutes to knock that out. And I'll pass out your worksheets.
So it's a lab day? Are you weighing the Sprite?
No, I'm heating it up. There's water inside.
Oh. I thought that's like a weighing thing.
Last period, I had one of my kids gave me a monster can, and it just took longer to heat up, so it took me like 3 tries. But now I have a tiny little Sprite. Maybe it'll work first try.
You're done with the graduation, but checking out.
Okay, we're good? Okay. So let me pull up. Oh, not getting scrolling. Okay, so we'll go over them real quick. Which state of matter has definite shape and volume? A solid, liquid, gas, or plasma?
Solid.
Solid. Which state of matter has definite shape and definite volume? Solid, liquid, or gas? Do they vibrate in place? Do they move freely? Do they slide past another, or they do not move at all? No.
Slide past.
They slide past each other.
Solid objects, they stay in place, but they vibrate.
Yeah, they vibrate in place. So this is more of a liquid. They just slide right past each other. Okay, which state of matter are particles moving the fastest?
Gases.
Gases. What happens to a particle motion when heat energy is added to matter?
Moves faster.
It moves faster. Think about our Alka-Seltzer lab when we did the room temperature, the cold, and the hot. When we did the hot water, it moved a lot faster. Okay. Why can gases fill any container they are placed in? Go for it.
They can move freely and spread out.
They can move freely and spread out. Good job, guys. Okay. Okay, so our introduction. introduction. So our learning target, students will work in groups to analyze and evaluate behaviors in gases with these examples. Students will then sketch what they see, write an explanation of what's happening in terms of our kinetic molecular theory, and justify which gases fits the best example. Okay, guys, we create and utilize models quantitatively, conceptually, and graphically to illustrate the relationships among pressure, volume, temperature, and the number of moles of gas. This includes examples of our Boyle's, Charles, Gay-Lewisic, and the ideal gas law. Continue on what we've been talking about. Okay. So our kinetic molecular theory, or KMT if you want to shorten it, states that all matter is made up of tiny particles, atoms, and molecules that are consistent or in consistent motion. Who wants to read the first one? Go for it.
It states three things. Gas particles are hard, small spheres with insignificant mass.
Okay, who wants to do number 2? Go for it.
Gas particles are in rapid, constant, and random motion.
Okay, number 3, Mary.
Collisions between gas particles are elastic.
Remember what elastic is? So we have inelastic and elastic. So our inelastic, our bouncy ball is stopped moving. Our elastic, they still have the same amount of energy. If you look at the little container in this picture, they're just moving around constantly. There's no loss of energy. Okay? We good on kinetic molecular? Okay. So, how do we think temperature and kinetic energy are related? How are temperature and kinetic molecular theory related? You guys remember?
Kinetic is energy that is rapid pacing and like
Keep going. As we increase temperature, it's going to be what? The same or different?
different.
Same.
It's the same, remember? Because as we're increasing that temperature, that particle motion is going to increase too, right? Because we did that lab and it moved faster. Okay? What happened to the volume of gas when we increase temperature? Is it directly or indirectly?
Directly.
It's directly proportional. They're the same. The only one that's indirect is pressure and volume. Okay. Can you think of a real world example where gas pressure changes?
Tropical climate.
That could be
Or
part.
maybe like places like, what do you call it, where it's like there's nowhere tornadoes are in there. Like
Yeah, because
Texas.
we would use our barometer and see the different pressures when we start having storms. What do you do underwater? You can go, what? Scuba diving, we're changing the pressure with all that water, right?
How do you think it is when it's in space since there's no oxygen? How do you think the barometer is measured?
It's kind of like that. They put you in a spaceship, a space suit in the spaceship that helps contain that pressure. Okay. So just a review of our gas laws. We have Boyle's law, that's as pressure increases, the volume decreases, so that's indirect, and our temperature is going to remain constant. So, real world example of Boyle's law is our breathing, our lungs, okay? As we increase the pressure, we decrease the volume. You could also do a syringe or a scuba diver. Those are all going to be real examples of Boyle's law. Charles' law, the volume of gas is direct, so they're going to be the same, of temperature and pressure. So think about a hot air balloon. Okay? So as we increase the temperature, the pressure increases. They move together. Okay? Gay-Lewisic, as the pressure of a gas is directly proportional to the temperature. So pressure and temperature again, and volume is going to remain constant. Okay? Does anybody have like an Instapot or a pressure cooker at home? or know what it is? Yeah, that's an example of Gay-Luisic. Because our volume is remaining the same because it's in a pot, but we're increasing the temperature so that pressure to cook everything is going to move faster. And then our combined gas law is all three, the relationship between pressure, volume, and temperature. You can also use a scuba diver for that, because think about the different temperature levels in the ocean, pressure levels, and then as you go different pressures, your volume changes. Are we good on the 4 that we're going to use today? Okay. For your lab, I kind of wrote a little cheat sheet on the board just to help you remember when you're going to fill that out. Okay, so station 1 is behind Austin. It's a little Coke bottle. Be careful when pulling this part, just pull very gently, okay? So this is our lung. So on your paper, you're gonna draw what you see, explain what's happening in the kinetic molecular theory, and then you're gonna give me which law best fits. So you should have 3 sentences for each lab, okay? And a picture. The second one is our soap explosion. You're gonna look at the before and after. It's behind Jaden at the second lab station. So I put the before and after. Do the same thing, draw a picture, explain what's happening, identify the gas law. Station 3, we're gonna do together. First is our can crusher, and you're gonna draw what's happening, explain, and give me the gas law. Okay. And then our last one, station 4, is the marshmallow vaccination. It's in that very back lab station. Make sure when you're doing it, you're making sure to put your finger over the top of the syringe, okay? And then you're gonna draw what you see, explain, and gas law. Any questions about what you are doing? No, okay. So, safety. We're gonna wear goggles. If I'm wearing it, you're wearing it. We're not horseplaying. There is a hot plate. Even when it's turned off, it's still gonna be hot for a little while. We're gonna wipe down our stations and follow all directions. Okay. For when you get to the explanations, I have some sentence starters for you to help out if you're having trouble. The evidence I observed was, I noticed that the gas particles were what? According to the kinetic molecular theory, gas particles what? So these should help you out. That's why I wrote the laws on the side of the board for you, so we didn't have to flip on slides. Okay, so go ahead, find a part, actually, grab your goggles and your pencil and meet me at the can. Ready? Okay. Pay attention, it happens quick. So what happened to the can?
It got crushed.
It got crushed, right? So we increased the what first?
Temperature.
Temperature. And so what's happening to the can after? No. Did we change the volume of it?
No.
No, so we changed the what? What's the other one?
Pressure.
Pressure, we changed the pressure. Okay, so go ahead and write your info for this one. I'll leave the can off to the side for y'all. And then you and a partner can move to any of the 3 lab stations. If you need help, let me know. If you're not sure about what gas law it is, just ask me, we can talk about it. So pressure and temperature. So which one, Matt? Gay-Luisic, yes.
Is it Luisic or
Luisic.
Luisic? I don't know why.
It's French. I have a hard time saying it in French. Luisic is the closest. Just be very careful, that hot plate's gonna be hot for a little while. I'll try to. So, on the one we had a full can that was perfect, no dents, and then I put it in the cold water and it crushed.
Was it pressure or that you just?
It's pressure and temperature, so scale it wise. Your sentence stems are on the board if you need them to help you fill it out. When you're done, you and a partner can go to the other 3 stations and work through them. When you're done, we're gonna turn it into the bin. Okay.
Was it a used can or open can?
You scan. It was open. Are you two done? Okay, go to the soap lab.
Oh no.
You're done. And Carter, why don't you guys go to the marshmallow vaccination lab behind them? And then Chloe, Mary Grace, and Jaden, you guys can be at the long and get that one done. Wait, what's this one? Yep. Anua, Carter, next lab, other one. There you go. So if you need more directions on what to do, they're posted on the lab station.
Before and after it was put in the microwave. Oh, this is the soap before?
Before and after.
Okay.
So how did the particles move? At least out, right? So I increased the what in the microwave?
Volume.
The heat. So I changed the temperature. And then what else happened?
Increase in size.
Increase in size. So the size is what? Would it be pressure or volume?
Volume?
Volume, because it's a lot bigger. Put your finger on it yet?
I don't know how to draw.
Alright,
I'm
so-
a bad drawer.
It's okay, just give me something. And then when you get ready, put your finger on it and you're gonna pull the syringe, okay? Watch what the marshmallow does. It stands up, right? And inflates.
Oh, it was. You get bigger.
Bigger, so what are you increasing?
Pressure.
Pressure and
Volume.
volume.
So,
Pressure and volume, that'll be Boyle's law.
Boyle's law, yep. You should have a minimum of 3 sentences for each one. Tell me what's happening, how it goes with the kinetic molecular theory, and what law. When you're done, you can just switch lab stations. You don't have to wait. If you're unsure how everything's going, talk to your partner about how the particles are moving. Maybe think of real world examples. And what evidence can you support your claim? Got bigger, so does the increase of what?
Pressure.
Pressure?
Maybe volume.
Volume, because we increased in the size, right?
Volume and T.
And I put it
charts.
in the microwave. Temperature, so it's volume and temperature. Charles. Yeah, just put your paper in the bin.
How you doing it?
Just pull a little, just find a little extra piece right there. Just don't pull the lid off. You know that?
No, I still have to do the driving part.
That's fine. You can do it at your seat.
Are you reading the same instruction?
I got idea with the pressure.
As you finish up, turn your paper in and start logging onto your Chromebooks, please. And heading to Google Classroom. I will give instructions in a minute. More volume. was our lung. What two things did we observe in this lab?
Pressure and volume.
Pressure and volume, so that was what? What law?
Boils.
Boyle's law. And we know that because we watched the particles in the balloon expand and deflate. Station 2 was our before and after of our soap. I put it in the microwave, so that's an example of what? In temperature. And then since that happened, what else happened?
The volume.
The volume expanded, so that's what?
Charles.
Charles' law. The third was our can crush, which we already talked about, that it was temperature and pressure, so that was galvanizing. And then lastly, our marshmallow syringe, if you put your finger on it, what happened to the marshmallow?
It expanded.
It expanded, so that's an example of what?
What?
Pressure.
Gave
Volume.
Volume. And since, when we put our finger up top, what happened?
It blocks air.
So that's what?
Pressure.
Boils.
Pressure. So that is Boyle's law. So you should have gotten all that. Okay, are we good about our lab? Do we feel good about it?
Mm-hmm.
Good, okay. That is it for today.